From entrepreneur to system builder, Elon Musk is no longer just a business leader operating within existing industries. He has evolved into something far more complex, a designer of large-scale systems that aim to redefine how civilization itself functions. His work is not limited to creating products or services. Instead, it revolves around constructing interconnected infrastructures that could fundamentally reshape the future of humanity. When viewed individually, his ventures, electric vehicles, rockets, artificial intelligence, brain interfaces, appear diverse and disconnected. But when examined together, they form a tightly integrated blueprint aimed at solving a single overarching problem: how to scale intelligence, energy, and human capability to a level that allows civilization to expand beyond Earth. In recent years, Musk's vision has intensified. It is no longer just about improving life on Earth, but about preparing humanity for a future where survival and growth depend on our ability to operate at a planetary and eventually interplanetary scale. This shift marks a transition from entrepreneurship to civilization engineering, where the goal is not just success, but continuity and expansion of the human species. The central problem: intelligence at scale. At the core of Musk's latest thinking lies a critical realization: the future of civilization will not be limited by ideas, but by the capacity to process them. Artificial intelligence is rapidly becoming the dominant force shaping technological progress, yet its growth is constrained by one fundamental bottleneck: computational power. Today's global infrastructure produces only a fraction of the compute required to sustain the next generation of AI systems. This limitation is not theoretical, it is already affecting how quickly innovation can occur. Musk has repeatedly emphasized that without a massive increase in computing capacity, progress in AI, robotics, and automation will slow dramatically. This is where his most ambitious concept emerges: a vertically integrated semiconductor ecosystem capable of producing computing power at an unprecedented scale. The Terrafab, rebuilding the brain of the world. One of the most significant developments in Musk's vision is the creation of what can be described as a next-generation semiconductor megastructure, a facility designed to produce AI chips at a scale far beyond anything currently in existence. This system, often referred to as a Terrafab, represents a complete rethinking of how chips are designed, manufactured, and deployed. Traditional semiconductor production is fragmented across multiple countries and processes. A chip might be designed in one location, fabricated in another, and assembled somewhere else entirely. Each step introduces delays, inefficiencies, and vulnerabilities. In a world where AI progress depends on speed, these delays become a critical weakness. Musk's solution is radical: collapse the entire process into a single, vertically integrated system. Within this environment, chips are designed, manufactured, tested, and improved in one location. Feedback loops are immediate. Iteration happens at unprecedented speed. This approach transforms hardware development into something closer to software: fast, adaptive, and continuously improving. Scale beyond imagination. What makes this system extraordinary is not just its efficiency, but its scale. The projected output of such a facility would dwarf the entire global semiconductor industry, producing computing capacity many times greater than what currently exists. This level of production is not intended for incremental improvement. It is designed to enable entirely new systems: billions of autonomous robots, massive fleets of self-driving vehicles, global AI networks operating in real time, orbital data centers processing information at planetary scale. At this level, computation is no longer just a tool. It becomes infrastructure as essential as electricity or transportation. Moving intelligence into space. Perhaps the most revolutionary aspect of Musk's vision is the relocation of computing infrastructure into orbit. On Earth, data centers face limitations. Energy supply is inconsistent, cooling systems are expensive, land and environmental constraints restrict expansion. In space, these limitations disappear. Solar energy is constant and significantly more intense. The vacuum of space provides a natural environment for heat dissipation. Infrastructure can scale without the physical constraints imposed by planetary environments. Musk's long-term plan involves deploying vast networks of AI-powered satellites, potentially numbering in the millions, that function as a distributed computing system in orbit. This represents a profound shift. The brain of civilization moves off-planet. the moon as a launch platform for civilization. As the vision expands further, the moon becomes a strategic component in this system. Unlike Earth, the moon's low gravity and lack of atmosphere make it an ideal location for launching materials into space. Musk has proposed the use of electromagnetic mass drivers, systems capable of accelerating payloads into orbit without traditional rockets. This approach could dramatically reduce the cost of space logistics, enabling the construction of large-scale infrastructure beyond Earth. In this framework, Earth becomes the origin point, the moon becomes a logistics hub, orbit becomes the operational layer. Robotics and the explosion of productivity. Parallel to this expansion of compute and infrastructure is Musk's focus on robotics, particularly humanoid systems like Tesla's Optimus. The goal is not just automation, but mass automation at scale. Musk envisions a future where robots